How are you beginning? Yeah, are we all right? Okay, so let's start. Good evening, everybody, and welcome to this GraphQL introductory workshop. Yeah, so it's nice to see that many people here. So most likely it's an interesting subject. At least it's a pretty much hyped subject in recent couple of years, and pretty much advertised that something like it's written here query language for your API. So some people saying it's the query language for your API. This. Now the idea is to see whether it's indeed what is so good about GraphQL. And but first of all, I want to ask you just a couple of questions. In fact, because we are all here with a lot of people, so it's like a representative set that we are having here. So how many of you guys are doing REST or has been doing REST? So I expect like 100%. Yeah, that confirms actually that currently REST is sort of a default way of communication between services and distributed systems. So everybody's doing REST, and but then there is another question. How many of you guys have ever had problems with REST? I mean, different kind of problems. Coding REST or as a client consuming REST. Like you say that, I mean, there is something that I want to improve, or I have having problems with some semantics, URLs, getting resources, consuming resources, serving resources. Yeah? How many people? Yeah, so real REST guru, they don't have any problems. They sit in, yeah, we like REST, so maybe for those people who really likes REST and don't have any problems, so they can simply maybe go home and have you know, well, a rest, a bit of rest.
Or maybe not everyone is actually doing REST.
No, but likes everybody. But anyway, okay. So you can stay out of curiosity what it is. So yeah, it's a query language for API, but okay. For now, for people who don't know me, my name is Sergei Storozhenko. I'm Java developer at Ordina, and currently I work at TVH as a consultant as a cloud automation engineer. So that's me, and now I want to start actually discussing REST, because that GraphQL disappeared just for reason. It's not just out of blue. So, and why? Because REST can be sometimes problematic. Well, I put this problematic in quotes because it's problematic for some use cases. For the other cases, these actually problems can be an advantage. But anyway, why can that happen? So first of all, let's see what REST is. Is it readable enough? I hope. So REST is actually an architectural concept for network distributed software, and it was first presented in PhD of Robert Fielding in 2000. So you see this, it's really very mature stuff. Soon 20 years, but it has no official set of tools. It has no specification. I bet that for some people maybe it sounds strange here, but it has no specification. Okay. It can use HTTP, but also any other protocol, just to transfer stuff via the wire. It doesn't care about the payload, can be JSON, XML, or any other kind of stuff. And my purpose actually of this is actually decoupling API from the client. But it's a big, let's say, advantage of REST is that maximally decouple API from client. But all of these can create a certain set of problems actually in practical work. And so what kind of problems there might be? So the first one is not adhering to specs and to wide interpretation of good practices. It's my kind of own classification. And the problems arising from the nature of REST. Now you're gonna say, yeah, okay, guy, you just said that there are no specification, and what adhering to what specs do you mean? Because there is no official specification. Okay. So what means not adhering to specs? So in fact, currently, the, let's say, default way of implementing REST is via HTTP with JSON as a payload. I mean, it's like 99% of people doing that. So, and if you do this kind of, if you implement REST in this way, you expect that it should actually adhere to HTTP specifications. Okay. So, like to use correct HTTP methods, headers, HTTP statuses, and all this kind of stuff. But I mean, it's never. But there is no actual mechanism to enforce this adherence to the specs. I mean, who did REST know that you can use, for example, method gets to delete stuff. Yeah, it will work. Technically, it will work. I mean, it would be crazy doing stuff like that, but it works. And there are more subtle, for instance, differences between put and post and batch stuff. Where it should be applied. Quite often all these things are actually misused, are used not correctly, but what is a correct way? So there are some good practices, okay, but the problem also that everybody creates own good practices. So big developing company says, okay, these are our good practices, we stick to these good practices, like, you know, this Zalando, famous Zalando API guidelines. I heard Adidas is good also. So, and then if you're consuming it, you should know those good practices, right? So I might know, and everybody should stick to them, but again, it cannot be enforced, and you can get some unexpected stuff there. Okay, and that unexpected stuff, for example, as I already mentioned, that wrong uses HTTP semantics like methods, URL structures, status codes, headers, and so on. Now there is that thing in REST which is called hate errors, which is the highest level of REST, the third level of REST, and yeah, everybody says, okay, we strive to do that, but it's actually adds a lot of technical overhead, and yeah, a lot of teams just opt not for using it at all. Yeah, so. And this is just an example that I actually picked up like a week ago. I was working with Jenkins Role Strategy Pro plugin because we are doing automation in TVH, and we wanted to use this, you know, this API to assign role to users and stuff like that automatically. And now the REST guru would immediately tell that, sorry, but this is not REST. I mean, this is not endpoint, REST endpoint get all roles, or add role, or assign role. So, and this is just an example that you can get this kind of stuff, and yeah, there is no documentation on top of it. So what you do, you go in the code, actual source code, and you what the thing is doing actually, and so on. So these are all problems that people might have consuming REST. Another problem that I call schemaless. Yeah, there is no schema in REST. Yeah, so nobody knows what this thing is going to return. Okay, and the only way to expose it somehow to the client to let know is just a documentation. So the documentation should be up to date, which almost never the case. And yeah, there is this thing which is called JSON scheme specification. Yeah, it exists, but I think it's still in draft actually. But I've never seen it's being used in my practice. I've never seen anybody uses JSON schemes. So anyway, that's documentation that should be used. But documentation very often is bad, or not lacking, or not really up to date, which is the worst case because you expect to get this, but you expect this something else, and then what? Another weak point of REST is actually the versioning. So it's claimed to be designed for evolution, but versioning is sort of tricky, and there are different ways to implement versioning, and ideally it should evolve actually without any versions. So it means that the server is gonna introduce always non-breaking changes, but And reader should be always tolerant. You know the concept of tolerant reader, that reader, the client, which actually gets, consumes the resource, should just ignore things that he doesn't know, just ignoring, yeah? It means that I'm accept everything and I'm taking only what I know, the rest I'm ignoring. So it means that actually a server can introduce changes to add something, and the client will not break if it's a tolerant reader. But how can you guarantee that every reader will be tolerant actually? There is no guarantee, especially the public API, for example. The other problems, actually, tolerant reader is tricky. If you ever work with tolerant reader, is that the reader that just accept everything, and you can simply use that reader to totally unrelated endpoint, and you will never get even an error. You just swallow it and gives you empty response, and then you scratch in your head, yeah, empty response. What does it mean? It looks like, you know, like catch an exception without doing anything with it. It just caught somewhere there, and this is it. So tolerant reading can be also tricky. Okay. And that absence of schema and relying on documentation requires actually consumer contract tests to be written. That's always a good thing to have. That will assure that if someone trying to do something, it will not break the contract between client and the server. But consumer contract tests is also sort of a problem because it's quite a substantial technical overhead that business doesn't like. Business will say, no, 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 I mean, it's working, we need actually stories to deliver, so those tests, yeah, you will do it sometimes, but no. So this is how it actually works in practice. So those tests, yeah, you should have really very well and understandable in business to allow you to write those tests. Okay. Then another problem that I would say, this is actually comes from the very nature of REST. It's a problem of underfetching. So it means that if you get necessary information, the client should navigate a number of endpoints, because it's not only one endpoint, but a number of endpoints, okay? And yeah, just to illustrate you a little bit, and this is already like a bit of stuff that we're gonna use in our hands-on next week. So if you have, for example, a certain employees endpoint, and you come here, and then you should, to get employees, you get a list of employees. But then if you wanna get information on one employee, you just go to the employee. And then if you want to know what car is employees driving, what car is inside, you have to navigate to this endpoint and get the car information. So, but the worst thing is, of course, if you want to, for instance, have a list of employees, but with the cars included, it means that you have to actually, if you have a list of 10 employees, you have to make 11 calls, because you get a list of employee, and then for every employee, you have to make a call to pick up the car for every employee. That's the rest. So for certain situations, it is okay, but for some clients, it's just really, I mean, so many calls just to load one page, for example. If you have mobile clients with a bad connection or something like that, that's not very handy scenario. And yeah, okay, the typical problem of solving this with REST is just to embed that car object inside. We embed it there, so the client doesn't need to do those calls to another resource to get those cars. It's already there. But then we might come to another problem, and that another problem is actually the problem of overfetching. So that means that, okay, yeah, we embedded that car, but some clients say, okay, I'm sending that request, I need just that, but server is receiving me everything about the client and car object on top of it. So it's pure waste. I mean, it's a pure waste. Okay. Of course, normally resources should be actually tailored per client, but if the number of clients is limited and you can tailor according to the context what the client works, that's okay. But otherwise, it's quite an overhead. And this is one of the use cases that we were having, for example, in Proximus. So we had a microservice, user microservice that was using like several backends as database, SOAP, some REST. And actually, to return the whole user information, you need to actually call all that stuff. And I think REST was extremely slow, like, yeah, returning hell of stuff. And then you have a number of clients, and maybe these clients don't need all of this. And can you imagine that if a client calls it and then you call all of these backends to return it, but it needs only information from the database. So typical REST solution is actually use the partials. So it means that, okay, this will be a query like include info1 and info3, so these chunks, and here this one's one chunk from here, this one will chunk from there. It can be also made even more granular, like include fields. I've seen this kind of stuff too. That works, but of course, the problem that like everybody can implement it in own way, and it's always an ad hoc implementation. You need to implement it and think how to implement it. It's also an overhead. So this is a stuff that you might have with REST. So I think I have convinced you that REST is good, but not perfect. And now, yeah, GraphQL to the rescue. Okay, with some question mark. Yeah. Maybe we will see whether it really rescues this or not, and what kind of problems it solves by the end of the talk. So, but definitely one of incentive to developing GraphQL was actually this imperfection of REST. Okay. So GraphQL was developed internally by Facebook, 2012. It was open source in 2015. And these are major, big guys who already adopted, implemented it. And the list is actually growing pretty fast. I know, for example, from this is GitHub. I know GitLab is now writing their GraphQL API. Okay. And yeah, if I show you the real list now, it's actually quite big now. So yeah, these are all guys now who already implemented and using this GraphQL. So yeah, Twitter, by the way. So yeah. So it's growing and developing pretty fast, actually. Okay, so let's see what GraphQL is actually. So what's GraphQL? Well, it's a query language. This QL, we know that QL it stands for query language. But there's also a specification. Now you see immediately the difference with REST. It doesn't have actual official specification. Here it is also a specification, and it has in fact a set of dedicated tools, so they're developing those tools and using them. And the one of the big difference operates with a single endpoint. You don't have it in 10, 20, 100 endpoints. The client should navigate through to get some information. It's always request to a single endpoint. Okay, and is actually optimized for flexibility performance. And what happens in GraphQL, that in GraphQL, the client is actually responsive, takes responsibility, not the server. So in REST type of communication, the client actually sends certain request and server just returns something. Unless there is no that includes something, the client just gets what server serves, and this is it. There is no way of client to change anything there. Now in GraphQL, client is the boss, and client says, okay, I need this, and it sends the query, and it receives actually exactly what it asks for, no more, no less. So you see that problem of overfetching and underfetching is solved here. Okay. So how it looks? So this is the query. So if you look at that query, well, it's reminds a bit a JSON somehow, but it's not a JSON. It's like a JSON with keys but without values. Okay, but actually it's a string. It's a string which is sent, but the response is is a JSON, in fact. Okay. And you see that simply these fields asked for, they are now filled with values. So it's actually mirrors that query, but it comes back at the same shape, but with values. Okay. This is how it looks. And if client says, yeah, but I need more, I need now also email and mobile, so client asks this, and it receives now email and mobile together. So what is asked for is received. That's the main principle and the main advantage of GraphQL. Okay. Most commonly now, everybody implements it via HTTP because HTTP is just a pretty much universal thing in everywhere, of course. And according to specification, it should actually support two methods. It could be get and post. So if it's get, then the query is sent as a parameter, request parameter. And if it's post, so the query is actually sent in the body. And what I see that people don't actually post because for many reasons you can put a lot of things in the body, but that stuff, it's if you get it, this huge query is also not very handy. Okay. Now, but then the question is, but how client knows what to ask for? Yeah, that's the reasonable question. So in REST you have documentation to read or no documentation, but in fact GraphQL is strongly typed, so everything is defined. So this is how, for example, object type looks in GraphQL. So it says type employee, and you can see here that the fields are mentioned, and actually they're all typed: integer, string, 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 and this is another type, car type, which is embedded in employee type. Now, those exclamation size mean that these fields are actually non-nullable. They should be always there, so it's not optional. Without exclamation, yeah, it's optional. Can be there, can be null, so this kind of stuff. Okay. Now, out of these types, they call scalars. These are primitives, actually, in GraphQL. They're integer, float, string, boolean, and there is a special type ID. Yeah, but this is what GraphQL specification says, often used to refer to an object as a key for cache. ID type is serialized as the same way as string. However, defining it as an ID signifies that it is not intended to be human readable. So, simply, it's kind of a type that should be used as ID, and it can be some lone hash, for example. Yeah, that's ID type. Okay. But by the way, those primitive or scalars can be also defined yourself. You can define, for example, date type if you really want to. There is a way of in GraphQL to do it. But there are other type. There are enums. There are interfaces. A special kind of union type where you combine couple. There is input type to input parameters. It can also use variables in certain situation, and can also use fragments. It's fragments. It means that if you have a query that is used in different places, you can define this fragment type and then put that fragment everywhere you really need to. So, but we are not going to do details of that because that would be like a deep dive session. We just want to see the principle here, right? So just to know that it's pretty much very well developed and advanced query language. Okay. Now, but where can you get all these types from? There is a schema. Yeah. So opposite to REST, there is a schema. And schema defined all possible types and actions, actually what you can do with those types. And schema is actual contract for all services, server-client interactions. So it means that, okay, you don't need documentation and you don't need to implement those customer-consumer-driven tests, whatever, because, yeah, you have that schema, and schema defines everything. It's in the schema. Now, schema has a tree structure, and hence the name of GraphQL, because tree is a graph actually, so GraphQL. Okay. And this is how actually schema looks. And these are actually special root types. You can also call them actions. So 3 types: query, mutation, and subscription. Now query is a default type. It should be always there. Your mutation subscription is not really necessary. It will work if you don't define any mutation and subscription, but schema should contain a query. The query is a query type. So how query type further is defined? For example, this is a schema to return employees. So type query, employees will return a list of employees. And now if you want to get a one employee, we use ID and we return employee. Now we return employees, so now we should define a type of employee, and this is employee type defined here. So this is actually the simple GraphQL schema that will actually work. So if you send this query employees, you will get a list, or if you send query employee, you will get one employee. Okay. And yeah, it's actually idempotent operation, like read operation, equivalent of get in REST. You can do it as many times as possible. You will never change the state of anything. Okay. Now there is another type, also action, is called mutation, and this is for all kind of change in state operations. You can create, update, delete, whatever. And you define type mutation. Of course, here you would define this type like as some kind of actions, because otherwise it's not clear what you're going to do with that and what you want to do. For example, this is type add employee, and then here you can state a number of parameters or arguments that you should actually send together with it, and it will return employee which is created or added. And this is in fact compulsory here. It should always return something. You cannot go without returning GraphQL. It will return employee, and for instance, this is updated employee. That's pretty much similar. And this is how the query, for example, would look to create an employee. Now you see that maybe if you remember my previous slides were showing you a query, there was no word of query here because query is a default type. So without any word here, it's just considered to be a query. But now here it should be really literally stated that this is a mutation. And then you say, okay, I want to add employee, I get a data of that employee, and this is already, after here, this is a return. That I want to get a return of that created employee object. And yeah, here can be ID or whatever number of fields that you want to receive back, or maybe just one or all of them, or it depends what you want. Okay. And there is a subscription. Well, subscription is pretty much says for itself. Yeah. So this is something that you want to subscribe and follow the real-time changes. So, and the query looks pretty much similar to the other query, the anything that you say type subscription. And well, it's just typically it would simply open a web socket, and just what's actually the changes will be pushed in the same way as is often pushed with the other kind of subscriptions. Okay. Now, well, important thing about GraphQL is introspection. So the whole schema can be examined and implored by the client. This is very important feature actually. So if you send this kind of special type of queries, like 2 underscores, schema type, kind field, so you can actually get back the whole schema. So client can always aware what is there and what it can ask for. That's pretty much handy. Again, you don't need documentation, and client, you can code client that will do automatically all this kind of schema exploration. Okay, so again, that's a big advantage as compared to, for example, to REST. And another one, of course, is a queries can be easily validated against the schema before the execution. So, and this is something really nice, because if your query is wrong and you're asking something that does not exist or whatever, something wrong, so before actually executing anything, the GraphQL engine would validate it. Do I have something like that in the scheme? No, it's not there. So immediately puff, return error. So how many guys of you really do validation of the call in the server in the very beginning? I know that you would pretty much find a code that would actually hit the database and generate error and then come back through all the layers. Yeah, again, yeah, because it's not enforced. Good developer would do validation. So. Yeah, but here it's just built in. You don't need to do anything. You just validate it automatically by the engine. It's just there. And for example, if here I ask for something like address, which does not exist in this resource at all, so you will get something like this. So this actually typical response, actual standard response of GraphQL. What the data is, it's where actually your response comes, but there is always an error array here. And that error actually returns errors that are found there. So you can see it states immediately validation error of field undefined address and so on. So with the full description, what went actually wrong there, because the validation again the schema, it didn't pass the validation steps, so no proceeding further, just bounce back with an error. Good. Now the next what we're gonna look at is how the query is executed. Well, because query has a number of fields, okay, and the point is that for the difference from REST, the client asks for some particular fields. So, and every field is actually backed up by a function which is called resolver. And that resolver should actually fetch the value for that field and return it back. So every field in that query should be backed up by the resolver, okay? And that resolver is actually a function of a method, where the argument is actually a previous type that's going to return the next type. And this is pretty much logical, because the GraphQL query is actually a tree. So you have a certain object, a node, and then you certain field, and then there is a next node, which is next field. So this one is already there. So to get something next, you really need to use something that you already have as an argument, okay? And then as soon as the resolver produces just a primitive scalar, the execution is finished. To illustrate it better, let's have a look here. For example, there is a query like this: get employee with certain ID. From employee, we need just email. Then we want to get a car. From the car, we need to have make, model, and then we want to get information of the leasing company of that car. So how the query is executed? So the first, you need resolver to get employee, okay? And you cannot go without resolver here. So you should provide resolver which would return employee object, but it would be, for instance, some database call, whatever. Yeah, you get employee object. The next field is email, and because email is actually a field and employee object, so GraphQL was actually looked at the getters, and it will say, there is a getter for email. It will use that getter to get email from the employee object. But further, there is a car, and car is not actually part of employee object. It's not there, and that's, by the way, important difference. So with the rest, you should embed, for instance, right? But here you can combine actually or embed objects, but in the schema itself but you don't need really to embed them in entities which are behind. So in this case, employee is just an empty entity. There is no car there. So GraphQL look at it and okay, car is there is no getter for car because there is no car there. So we need a resolver. So we provide resolver, find car, and then employee has, for example, license plate as a, let's say, we can consider as like a foreign key. So you see, we actually provide employee as an argument. We get a license plate, and there's another database call. The car object is returned. Now make, it's a getter from that object. Modeled again as a getter from that object. Automatically done by GraphQL. We don't need to do anything there. Okay. Then listen company again. It's another object which is not in the car. It's something separate. We need to provide again a write a resolver for that one. Again, get company and use car, in fact, as an argument, because that's what we have here. Okay? And we return this, and then we return listen company, and then name of the company is there. Getter is used, contact person. Getter is used, phone, getter is used. So this is how actually GraphQL engine would perform, would execute query. It will actually really go through all the fields and would search for getters, for resolvers. Either will be getters, or if there is no getter, so developer should write, okay, write a resolver here. So this is a resolver, just get it there. So, okay, so I hope it's more or less clear how the thing actually works. Okay, now another interesting thing here that you say, okay, it's a schema, but if I have like a 100 microservices and it's a big API, how I should write it, you know, that huge schema there somewhere, make it this huge schema. So there is a solution for that which is called actually schema stitching. And suppose that there are a number of microservices, a number of backends. So here there are microservices, every one has in fact a GraphQL endpoint. But there is one that would use the GraphQL client actually to call this one and get fields from here. Okay, and this is something that now is transformed and it's also implemented in, for example, Apollo framework is called GraphQL gateway. So it will actually expose the whole of these as one big schema to the client. So client will not know where it goes, but then this gateway will actually direct to another microservices or whatever services exposing another GraphQL endpoint. So for the client, it will still be just a single GraphQL endpoint, but on the background there might be as many as you want, but this schema is just stitch from different pieces, created one and exposed as one schema to the client. Okay. So next feature, it's evolution, versioning. That's also a nice one. Why? Because it's very easy. You can easily, server can easily add fields there. No problem at all, because client ask what clients need. If there is something there, it will never be asked, it will not break clients. So that's kind of obvious. So you can actually change your things, your resource that you return. You can add fields. Maybe other clients are gonna use them, but the existing clients will never break because it will never ask for that. Okay. So if you add here social security number, okay, the old clients will be simply getting what they wanted, and they will not even know. Okay, they will eventually because they will pull the schema, but they don't need it, so no problem. But on the other hand, I don't know. No, it's just it depends on the implementation. So you might even explore key schema. I believe that it makes a call and cache it somewhere. So, but how often? Depends how you write the client. Most likely. Now, there is another thing, nice thing that can be implemented is actually field deprecation. Suppose that you want to deprecate in certain field, you can annotate it like at deprecated. This kind of annotation is also, it's called directive. It's a sort of action in GraphQL. It's reminds all other kind of directives that people use in other languages. So it is sort of an action on that field. And it can be, you can write a directive at deprecated, for example. So the client then knows that, okay, the field is deprecated. It's gonna get rid of it soon, okay? And you can write in this deprecated directive in such a way that the field is not even exposed in the schema. So new client comes, it will not see it because it's already deprecated, but the old clients will still be using it because it's still there. So that's a pretty also good feature for the evolution. But it can be done also in an intelligent way because server can keep statistics, full statistics of fields, usage of fields. And at certain point after deprecation has been announced, if servers see that, okay, for a long time nobody's using these fields anymore, there are no requests for these fields, there are no clients who are gonna request it, so it's like everybody is already switched, everybody knows, so it can be safely removed. Okay, so now n+1 request problem. So that's the problem of REST that I mentioned in the beginning, that if you want to get something, sometimes you can have to make a number of calls because, yeah, you have to navigate through the endpoints. So here, client doesn't have this problem definitely because client calls just only one endpoint, okay? Now, here this n+1 problem still exists, but it's shifted actually to the server. So server side is still there and it should be solved. And yeah, you can have just a couple of solutions that, for example, you can make asynchronous calls or use a special kind of stuff which is called that Dataloaders. Yeah, to illustrate it again, you have this get employees. That's the query, for instance. Yeah, so you want to get employees and you want to get a car. And then to resolve this query, what backend should do? Backend should actually, for a list of 10 employees, it will need actually 11 queries. For example, database queries or query some backend, which is some other API, whatever. Why? So the first query is to get list of employees. But then for every employee, resolver will start resolving fields and will start resolving this car and making calls for every employee getting this car. So it will be 10 calls to car. Yeah, which is not efficient. So you have asynchronous resolvers. Okay, it's in Java code. It's, yeah, you can return some kind of future promise in other languages can be promise. Normally, most of GraphQL agent, they just really support it out of the box. So you simply write that. And all those calls for 10 cars will be done actually async in parallel. So it will be faster, definitely. But yeah, there is still a problem because if those fields, for instance, and different kind of objects, fields that goes to different backends, that really improves the thing very nicely. But if it's, for instance, the example that I just mentioned, if you need 10 cars and you do it in async, then the question is how your backend is going to handle those, because you get just concurrency. And if you have too many of them, the client maybe cannot handle it well. For example, a limited thread pool which will saturate it, and then they will be anyway put on in kind of a queue while the new thread will be ready to process. So it can improve, but to a certain extent. So there is another thing which is better, is a Dataloader. It's also utility specifically designed for GraphQL. And it's actually part of data fetcher layer. So what it does is actually simplify those tasks and improve efficiency and performance by batching and caching. So if you look here, so if you have a resolver that should call to get certain data from the backend, so Dataloader is somewhere in between the resolver and the backend. Yeah, it's a library actually which is provided normally. And how batching works? Again, we have the same thing. We have get employees and amount of employees. So you make a call get employees, and then we have to make again this get car1, get so n calls to get them. But there is a data loader which is in between, so it does not allow to go to the backend directly. What it just does batching, and it does something like this. So in terms of, for instance, database query, you would implement it like where cars ID in, for instance, yeah, and then you can get a certain number of all these IDs. So they are actually all picked up in one go. Of course, you need to provide, and your backend should support it, and you need to provide that function. So Dataloader will not really allow to all these 10 calls go. So it simply batches all the IDs and then send this kind of one call. So this is how Dataloader batching works. Okay. The next one is a caching. It has also caching. Suppose you have similar thing, but we have here also leasing company hanging around. You can imagine that this leasing company is gonna be repeated all the time because 100 cars in the company, okay, 600 maybe cars in Ordino, like a 4 leasing company. So it will be repeatedly returned the same leasing company. So what it does, it just caches it, and yeah, return is from cache. But the point here to know that Dataloader caching is just a caching only in scope of one request. It's not a real caching that we normally say, okay, like caching in REST. Yeah, it's just a scope one request. If there are some repeated calls, that should be the same repeated calls, they just cached, and it takes it from cache. So this is Dataloader, and yeah, it's supposed to be increased performance pretty well. But now we are coming actually to a next part to say that not everything that bright in GraphQL is compared to REST. And we came to the caching, because we mentioned caching, and that's a real caching. And this is where REST is much easier to deal with, because in REST, if it's implemented via HTTP, so that just the normal HTTP caching works pretty well. Yeah, so it can be, so in actually URL, because URL is a unique for every call, so it's a unique identifier. It can be used just a key for that caching. Okay, and you can, client can cache it using the URL, and you can even put that some kind of a caching proxy like Varnish or whatever somewhere, and which will be caching the stuff. GraphQL will not work. 2 reasons. First of all, it's only one URL which is not unique at all, because it's a post in most of cases. Okay, post not cached, by the way, and there is no identifier, so it's not cached, and there is no unique identifier. And what specification of GraphQL says about it? So if there is no identifier, so server should provide a client with that identifier with which client can cache it, let's say. So, and one of the possibility is providing object ID as globally unique identifier. What it means, for example, you say, okay, get employee, and server provides some kind of ID, which is some hash, which is unique through the whole API. And that would mean that this call get employee will be actually unique call that can be cached using this ID. Of course, yeah, there is always the point here that you cache something, but if it's a really dynamic nature, if the client would ask less fields, I have to do it again. But anyway, this identifier is supposed to be used for caching. This only one way of implementing. There are some actual specially designed libraries that deal with caching. So it's not that bad because you can use a library for that. Okay. But there is first the next thing which is similarly unique for GraphQL, and yeah, it's blocking of malicious queries. So because I mean you expose the whole schema to a client, the client knows the whole schema. I can imagine that is huge schema. So malicious client can simply make a query and say, okay, just return me just everything what is there, something like that. Of course, yeah, most likely it will crash the whole server, because so that's why you should really deal somehow with that. And there are a number of things that people are actually using to deal with blocking malicious queries. Is the very simple and in the beginning very naive approach is just size limiting of the query, because if the query wants to return the whole schema, it should be also big as a schema. So you can imagine that the query comes back, and you can simply look at the size of that string, because it's a string, and say, ah, but it's too long string, I will limit like 100 characters, no more than that, something like this. But this not really very good approach, because you can have short fields, you can have long fields, and there might be still malicious queries that uses short fields, and some innocent query that use long fields, stuff like that. So it's not much of control there. So then depth limiting. That's another approach, because you have a tree, so you have levels on the tree. So the depth limiting is say, okay, we can go just that deep and no more than that. And yet it will work, but it might be use cases where some clients want to really go too deep, and that will cut them off, which is also not a very good idea. Now, another approach is a query white listing. So that means that actually server would cache all the query that it receives. And if you have a set of known clients, you know that those clients are sending these kind of queries, and they are innocent. And all those queries will be actually whitelisted by the server, so they are kept there. And every time the query comes, it's okay, that's on the list. We allow. But on the other hand, again, if you have a new clients coming, you have always add a new one on the query, so it might grow. But anyway, it works. But apparently one of the best one is a query cost analysis. So what is query cost analysis? Is because every query has a certain cost to get data. You can imagine that, for example, based on the number, for instance, of resolvers that can be used, and if they just getting some simple fields from an object, which are getters, that are very cheap queries. It's very cheap fields. I mean, it costs nothing. But if it's a call to some backend, some complex stuff, the cost of that field is much higher. So based on that, there is a certain algorithm that calculates the cost analysis of the whole query. I'll say, okay, this query is not that costly, we will let it pass. If this query is very heavy, costs too much, we just block it. Okay. So there are ways to deal with it. Okay. Now, there are many other things that can be still discussed in GraphQL, but I think we had already enough for the introduction. There is also authorization, for example. It's also a big and special subject. But what about implementation? Well, GraphQL is an interesting case because it was implemented and designed as Facebook, and it was implemented in JavaScript, not JS. So it's actually there, it's the most comprehensive tools and frameworks are there in JavaScript. One of those is Apollo. It's a very big, nice platform. You have there everything just to really to roll out nice GraphQL. Okay. and it's called also reference implementation. I mean that now is they started implementing in all languages, Java, Go, C, C++. I don't know about Encore, but what they do, they look at JS reference implementation and simply port it and, and implemented the same things in other languages. Okay, so yeah, I'm a Java developer. We are also G-work, so we work with Java. So what about Java? So there is official GraphQL implementation, which is GraphQL Java. And there is a very good place to start is GraphQL Java Kickstart.com. So it's kind of a wrapper over this official library, and what is also good about it, it provides also a Spring Boot starter. So it's very, very convenient to work with because there is a Spring Boot starter, and this is a framework for schema first approach. It means that you first design a certain schema, and then the engine will actually parse that schema, and then you need to implement all kind of resolvers according to that schema. But there is very actually interesting library which is called GraphQL Speaker, and that I heard about in these DevOps. This one is code first approach. So that means that you write just some methods that return some stuff that you want actually to, to expose. And then the agent, you annotate them with certain annotation, and then the agent will simply build the schema for you and just really expose it. And okay, in Java there is no GraphQL client, because you would say, okay, for example, if I want to use GraphQL communication between, let's say, Java written microservices, you would want also a client. But in Java there is no client, but there is a client for Android, which is basically Java, so it's gonna work. And there are nice tools actually. There is all in-browser IDE for exploring GraphQL. This is something which is called GraphQL. And this GraphQL is actually a tool that's written in JavaScript, and I can actually show you how it works. It's a nice thing, pretty. So you can use it as a nice tool, to explore scheme and run some queries. So this is actually more or less the API I was talking about now all the time during this presentation, and it's something that we're gonna do next week in our hands-on. So here you can write some queries, and here you can get responses. So you see this query like get employees from employees. I want to get a list of employees, I want to get a car object, and I want to get a mail. And I say, okay, I want for employees, I want also have last name, first name. As you can see, because it knows the schema, it asks for a schema, so it gives you immediately, prompt what is there, so you cannot go wrong with that. See? First name, last name, like whatever, mobile, for instance. And then we send it, and now we got this list of employees, and now this thing is present. If you want a car, we're gonna get a make, for instance, and something like maybe body type. Now we're getting all this data here, see? So the same way works mutation and other things. So it's a nice tool. You can always use it if you're developing a server side, GraphQL API. You also, in fact, explore schema here, because they say, okay, this schema has a query and mutation, and look what kind of queries. And the queries are get employees, get car, so it's here. And then you have employee type, and it says what is in there, and it's employee type. You have car, then this is a car type, so you can do explore schema also in an interactive way, which is pretty cool, I think. So it's it's a bit like a postman that you use for REST, for example. So that tool is pretty useful for GraphQL. Okay, let's go back to the presentation. Yeah, okay. The verdict. So we were talking about GraphQL, comparing to REST. So there is that. Sorry. What can I do about it? No, it doesn't work. Wait. What I see here, that stuff that is coming. Okay, now it's okay. So then the question is is GraphQL is actually better than REST? And yeah, that's apparently you can find good cases, use cases of GraphQL. You can still use all good REST. And so when would you use GraphQL? So if you need a highly queryable API, and if you expect an array of clients, a lot of clients that need smalls and different datas. And small, actually, small, it's a key word here also, because as I saw, I mean, if your query is huge, yeah, it's not good. So it's pretty much if you have an actual very dynamic environment, plenty of clients that gonna ask some dynamic data, small data, that GraphQL is good. Now, if you can restructure data to be inexpensive to query, because you can imagine, for example, you have a big REST API, say, I want to do a GraphQL, but it's a huge API, and then you have to build that huge schema, restructure everything. You always have to think twice, do I really need it? If I'm sitting in, let's say, enterprise environment, and I have like 3 clients consuming it, and I can communicate with these clients as pretty much static, they consume it every time the same thing. Why would I actually use GraphQL for that? I mean, if it's the same all the time. So, yeah, that's where you use GraphQL and where your GraphQL would shine actually. So what about REST? Yeah, as I already said. So if you write in a really good way, so with careful evolution instead of global version, yeah, you really need to take care of everything, that you don't really just expose the database, but you really expose data and on a needed basis. So it also implements some sparse field sets, not like returning like the whole database in one call, but really depending on the bounded context, returns all the really fields that needed for that bounded context. If it gets gzips context, okay, then it will be more compact. Yeah, if you use JSON schema, nobody uses it, but it would be nice to use JSON schema actually. And okay, follow all kind of known good practices. Then the advantage seems to fall a bit short. I took it actually from Phil Sturgeon blog. He compares it very well, and this conclusions more or less he comes with. And this is something that I think also sounds quite reasonable actually to conclude this session. Yeah, and that's the first slide for the next week for people who inscribed to try a bit to get their hands dirty and do some coding. But this is Java, so okay, thank you very much for attention. If you have any questions, please, but I mean, I'm not a GraphQL expert, so that's something that I learned and liked, very useful, very interesting, and I just want to share it with you. Yes, this is about our authorization. You're talking? Yes, indeed. So authorization actually is interesting subject there, because indeed you can actually expose only certain field to certain clients, and for that you can use in fact those directives. You can annotate field For example, with certain annotations like at authorized, and then you can put a role there. So for certain role it will be visible, for certain not. But it's not only even blocking the content. You can actually block certain fields, certain types. They are not visible for clients at all, which is also a very good thing, because in this case, I mean, for the hacker, knowing what is there without knowing the value, it's already a big thing, but they will not even know what is there if you really block part of the field, because it's actually field resolution there, so you can work per field. And what I heard also in a talk, it's already something different in a talk of on the DevOps. You can also use caching per field actually. So there are some guys using directly like at cacheable, and they annotate field at cacheable, and then they cache somehow per field. I don't know exactly how it is implemented, but it's also something that people actually working on. Oh, that's very interesting question. Something that I didn't come across, in fact. Yeah, it's most likely you should serialize them somehow. Yeah, indeed. Yeah, sure, but you can do the same way as you do in REST. I mean, you can in REST you would not expose your database. You actually make a certain object what you called a resource, and this resource will be depending on the bounded context. You expect on expose only certain fields, but you would design schema the same way. You simply provide a certain resolvers that would do it. But what I found also very interesting in GraphQL as compared to REST, because you don't need, in fact, to have nested objects at all, because objects can be just plain object, but you can combine them and embed them in GraphQL, provided you give a right resolver, and it will combine everything for you.
How does it work with nested objects? Is it exactly the same as with not nested? In the GraphQL query, you did employee and then car.
Yeah.
But what if car would be already embedded in the employee object?
Then you will not to provide car resolver, because the getter will be used to get the car in there.
Probably if you provide the resolver, but for the rest, it remains exactly the same.
Yeah, it's exactly the same indeed. Yeah. Okay.